So my name is Gbadegesin, and I'll be talking about the networking stack in Vista, some of the changes that we made, why it is that we decided to overhaul the stack at this point. And you can think of this talk as a continuation of the talk that John Lambert just gave on the overall security principles that went into the development of Windows Vista and how those were realized in a specific area, in a domain-specific area, which is networking. So just getting started, a little bit about myself. I'm responsible for the architecture of the Windows transports, which includes everything from TCPIP to legacy protocols. And it also includes everything from the network driver interfaces that our partners use to build drivers for Windows up to the Windows socket stack and the HTTP stack. I've been working on various areas in Windows networking for about 11 years now. And the past 6 of those years have been spent on what I'm going to talk about today, which is the redesign of the stack. So I'll be sort of moving back and forth between a very detail-oriented discussion as well as a high-level discussion about how we were thinking about some of the things we were doing. Hopefully that'll give you a feel for not only what we've done, but also where we're planning to go in the future. The way to think about the stack is that it's really a starting point for a set of things that we want to do and ways that we want to advance the platform and secure the platform for the next 10 years. So how do we approach something like this? Well, I mean, you have an old stack that's up and running, it's working. People are more or less familiar with it, even if they may not be happy with it all the time. The only reason to replace a subsystem like that is if you can make a significant step forward in its functionality, in its security, in its extensibility. And the way to make that kind of leap is to look at it from a different perspective. The way that we approach it is that we try to imagine who are the customers for the networking stack. So we have end users who basically really only care that the networking stack works and that it gets great performance for them. We also have folks like administrators who care primarily that it doesn't cost them extra money to maintain the networking stack. In other words, deploying a network shouldn't basically result in a ballooning of their support costs. And the flip side of that is that they want it to be secure. Then we have partners who, everyone from folks who build systems like HP and Co. to folks who build hardware devices that plug into the operating system. They care that their devices are supported and that the systems they build have great scalability and deliver benefit to customers. And then finally, in many ways, the toughest crowd of all, developers. This includes everyone from folks who write software that runs on top of Windows to folks who build security solutions. A lot of the people in this audience may fall into this category. The reason they're the toughest crowd of all is that they have fairly clear ideas about how something like networking should work, and they're not afraid to tell you. So you have to take their expectations around having APIs that are rich and clean and being able to see into the networking stack and being able to extend it and balance it against all the other considerations that you have from all the other categories of customers that are served. You put all of those together and you come up with a set of fairly concrete, easily understood things that are going to guide what you do in overhauling the stack. So this is how they sort of break down for us. The first is that we wanted to achieve something that could be referred to as the state of the art. In other words, when you think about how a particular networking problem is addressed, whether it's how you run over high bandwidth networks or how you secure an operating system, a machine that has network capabilities, we wanted people to be able to point to the work that we've done and say, that really did advance the state of the art, and there's some really useful new thinking there. The second is that, and almost something that follows necessarily from that is that to be the state of the art, you have to be extensible because the state of the art is always advancing, right? You have to enable people building new innovations, new ideas on top of the networking platform that you provide. And then the last two are also closely related in that in the same way that the state of the art is advancing, the security threats are constantly advancing. And to cope with that, the security profile of the system has to be constantly advancing. And you have to think through what that means for each of the capabilities that you build into the networking stack. So a little bit of history. Because TCP/IP is such a low-level component, because it's kind of the first line of defense, we've been dealing with security issues much longer than virtually anybody else in the application stack in an operating system. So going back to early attacks, LAN-D, et cetera, which sort of focused on specific protocol vulnerabilities or implementation quirks, all the way to what we're seeing today, where you have denial of service attacks that are really more and more aimed at profitability. We've been there through the whole scope of that experience. We've witnessed the implementation of the security development lifecycle. We've had to put in procedures and processes to deal with these things long before, there was even before the ecosystem that we think about and kind of take for granted today existed. So as we replace the stack, we want to preserve that history. We want to preserve all of the work that we've done in the past, and we also want to advance and move forward. So I mentioned that we've been working on this for about 6 years now. So what does the timeline for that look like? Well, way back in '99, we started making the first architectural decisions and getting the system up and running bootstrapped. So our first milestone was basic UDP sockets over IPv6. An interesting thing that isn't commonly known is that the new stack actually began its life as an IPv6 only stack, and it was later that we added support for IPv4. The reason we did that is because there were certain capabilities in IPv6 that we wanted to make sure we had a consistent experience for. We didn't want to start with IPv4 and then bolt on IPv6 later. We started with the new networking protocols, and then we backported a lot of the logic from the IPv6 protocols into IPv4. The second big milestone was actually getting TCP data exchanges up and running between two machines running the new networking stack. That happened in mid-2002. And it also included some of the work that we did early on connection offload. And then the big milestone really is late 2003 when we were able to check in the new networking stack into the Windows, what was then Longhorn Windomain builds. So by this time, we had already completed, basic functionality paths. We had already gone through a couple of internal security reviews. We had already built up a body of scripts that would allow us to exercise the capabilities of exercise a lot of the old attacks that were known for the old stack against the new stack. And that was how we were able to get in. So in many ways, the stack that I'm talking to you about today, that I'm about to start going into detail on, is already about 3 years old. And so for us, we've grown familiar with it already. Now, you can overlay this timeline on all of the product development that was going on simultaneously. The same team that was working on the new networking stack was also supporting Windows 2000. We shipped Windows ME and Windows XP while we were working on this. Windows Server 2003, XPSP2 was in fact a lot of the things that we did with the firewall and with the changes in networking. They were backporting stuff that we had already done for the new stack onto XPSP2. And that just continued going down the line. We ended up backporting also some of our connection offload capabilities onto Windows Server 2003 SP1, which we talked about quite a bit at the Windows Hardware Engineering Conference a few months ago. So these are the folks who have been doing this work. The team has grown quite a bit since 1999. These guys include the folks working not just on TCP/IP, but also IPsec, the base firewall platform, which I'll talk about in quite a bit, and then the tools and utilities that pull the whole thing together. This is a look at some of the architectural decisions that we made early on and that guided our work. But rather than sort of talking to this diagram, what I thought I would do is I would jump into the debugger. And for those of you who are familiar with the older networking stack, this will be an interesting look at how much exactly has changed and how we've rethought a lot of the things that we've built. So let me switch over to command prompt. What I'm going to do is I'm going to use the user mode debugger. So I'm actually looking at the system that's projecting this presentation on the screen right now. So the first question is, how do modules actually fit together in the new networking stack? What we did is we wanted to be extensible. So we started out with IPv6. We wanted to easily be able to drop in IPv4 support without having to change anything in TCP or UDP. Right? So what we did is we defined what the broad levels of functionality were, and we defined interfaces for components to talk to each other. And I can enumerate some of those components right now. So for instance, I can dump out, actually, so this is a list of just some of the components that are registered as clients of the various interfaces that we expose in kernel mode. I won't go into detail about this except to show that at any given time we know exactly what's running and how the components interact. Similarly, I could dump out a list of the providers. This architecture of bringing components together flexibly allows us to do things like our test team has harnesses that they can execute that will wrap the TCP implementation at the top and at the bottom, and that will actually exercise the entire TCP state machine and all of the various APIs that we provide in isolation from IPv4 or IPv6. So if there's any capability that's in the interface, we want to be able to exercise it, even if it's not something that you would see in a normal deployment on the network. So that was the key thing that we wanted to get out of this approach to bringing components together. Similarly, when you actually look at the implementation of the network protocols, we wanted to share as much functionality as possible. So if you think about how the functionality breaks down between TCP and IP, TCP maintains things like connections and endpoints and so forth. IP maintains addresses, interfaces, and so on. We sort of we manage that split as well fairly consistently. So I could dump out, for instance, a list of all of the components that are registered as transport modules. And on this system, I have a UDP transport, I have a TCP transport, and a raw transport. I can dump out the contents of these structures. So let's take a look at the UDP. And you can see sort of how it connects with both TCP, with both IPv4 and IPv6 at its lower edge, as well as with clients on top. Similarly, I could dump out the IP, let's say IPv6 state, which includes everything from its configuration to how it manages communications with upper layers and how it manages addresses and so forth. So if I dump out, for instance, the interfaces, actually that's something that's more easily done from. So here's just a quick look at NetShell, which is a command line program that we built to make it much easier for, without using the debugger, to look into the state of the system. So I can dump out the list of the network connections that I have, both the ones that are connected and the ones that aren't. I can switch back to the debugger and dump out a list of all of the addresses that are in the system, including both IPv4 and IPv6 addresses. So that covers a little bit of how components fit together and how we maintain runtime state. Similarly, I could go into quite a bit of detail about how we handle I/O. That has also changed significantly since Windows XP SV2. However, the reason that I'm sort of giving you a feel for how much scale of change there is to pose the following question. If you have a solution